Alright, on to what is acceleration. It's not the same as velocity. Acceleration is a rate of change. A rate of change tells us how much a quantity gains for each unit of time. If you work at a job for $15 an hour, the amount of money you have, quantity, changes or increases by $15 for each hour, a unit of time, that you work. Hourly wage is a rate of change of money. While driving on the freeway, the rate of change of gasoline in an average car's tank is 5 milliliters per second. This means the amount of gasoline in the tank decreases by 5 milliliters every second. That's a quantity and a unit of time. Quantity over a unit of time. Note that negative rate of change means the quantity decreases with time. Acceleration is the rate of change of velocity. I don't know where I am. I need to find my picture. Acceleration tells us how much velocity an object gains every second. We measure velocity in meters per second, right? That means acceleration is measured in meters per second gained every second. So meters per second every second. In math terms, that means the units of acceleration are meters per second, or meters per second. In math, if you divide seconds twice, the seconds just get squared, so the units of acceleration are meters per second squared. I'm going to show you that written out. So if we have meters over seconds. Okay, so, well, what about keep, change, flip? Then you would keep, and you do the change, and you flip, and then seconds get multiplied. And then it's just you're left with meters, right? No, that's not how keep, change, flip works. Whenever you have a complex fraction, and you have the fraction in the numerator, then that means, this is the little fraction in the numerator, then that means it's too heavy, and all of this junk is going to collapse. So what you're going to be left over with is meters over seconds times seconds. Okay, so that's kind of a nuance that I see a lot of students not fully prepared to handle when they get to me. So just remember, if you have a fraction in the top, it's super heavy and it's going to cause the whole thing to collapse and everything's going to fall down. So here we are again. We see the red car going 20 meters per second every second, and the blue car going 2 meters per second faster every second that goes by. That is acceleration. Your velocity changing based on time that goes by. Acceleration happens when velocity changes in any way. Any way. So if you are moving forward, and then all of a sudden you're moving backwards, that's due to an acceleration. If you're moving forward and then all of a sudden you come to a stop, that means you had to have experienced an acceleration. If you are moving forward and then all of a sudden you're veering to the right, that means you are experiencing an acceleration. Velocity is speed, which is a magnitude, with a direction. If an object's speed changes, then we say it has tangential acceleration. Tangential acceleration is what the gas pedal and brake pedal control for a car. Let me break down that word tangential for you. So a tangent line is going to, on a curve, is going to be a straight line that just barely touches, just barely kisses that line at exactly one point. That would be your tangent line. If we are already moving in a straight line, we'll go ahead and keep our colors the same. So we're moving in a blue line in this direction. Then our tangent line is going to be just barely touching this. So it's going to be in the same direction. Okay? That's what I mean by tangent. So tangential acceleration happens when an object's speed changes. Now, if an object's direction changes, then it has a centripetal acceleration. Centripetal acceleration is what the steering wheel of the car controls. So you have two different things changing. You have this, the direction or the speed changing, excuse me, not the direction. The speed is changing, and then you have the direction changing. So you have two accelerations happening at once in your car. For now, objects are only going to travel in straight lines, so we're only going to deal with tangential acceleration. That's not a permanent thing. We will absolutely deal with centripetal acceleration when we are dealing with things moving in a circle. Here's the formal definition of acceleration. Acceleration, which is a vector, is delta. Remember, delta is our change. That's our final minus the initial. Delta v, or velocity. I know it's velocity because it's a vector. It's got an arrow above it. Divided by the change in time. All rates of change are change in a quantity over the time it took for the quantity to change. Acceleration is a change in velocity over the time it takes for the velocity to change. Note that acceleration has an... We already talked about that. Plug in the units. The units for velocity are meters over seconds. So now we got that small fraction in the top and the numerator. It's heavy, so we know it's going to collapse. Meters over seconds is the same as 1 over seconds, multiplying the reciprocal, if you like an alternative math definition. I like the small fractions on top, so it's heavy and it collapses, but, you know, whatever works for you. We'll deal with this next.